Hey guys, welcome to Unit 8A, Section 1. This is the introduction to our two circles units, so we're going to be using these words a lot. Some of them are going to be familiar and then some of them are probably new to you. The very first thing is to define a circle, and that is all points in a plane that are equidistant from a fixed point. So they're the same distance from what we call the center point. The next word is radius. You've definitely heard this one before, and that's a segment connecting the center of a circle to any point on the circle. We can have multiple radii, that's the plural name for radius, and you can have, like I said, multiple, but every single time they're going to be the same distance because they're extending from the center halfway across the circle. Then you have the diameter, which is a segment connecting 2 points on a circle, but it has to go through the center. So we can have an infinite number of diameters and radii, because you can pretty much go from wherever and create them. Just remember that the relationship is diameter equals 2 times the radius. The next part is, these are some of the newer parts. The first one is a chord. A chord is a line segment that intersects a circle at two distinct points on the circle. Okay, it is not going to go outside of the circle. That is one thing you've got to be careful of. A chord is on the circle between two different points. Technically, the diameter is a chord, but the specification to be a diameter is it has to go through the center. General chords don't usually go through the center. And then we have a secant. This is a line, so it goes on forever and ever, that intersects a circle at two distinct points. Similarly to a chord, here's our secant down here. Notice it would intersect at this point here, but it has the arrows indicating that it's continuing on forever and ever. So that's the difference between a chord and a secant. And then we have a tangent, which we've heard this word before, but what tangent means here, it's a line that intersects a circle at a single point. So it can only touch at one point. It gets really, really close, intersects at one point on the circle. All right, so looking at this, the first one, a tangent. So we got to find where it touches at one point. Now this would be, you could say multiple answers for this. You could say line DB, the arrow over top, or we could say line BE, or we could say line DE. Any of those three would be acceptable because they're all the same line and they touch at point B. The chord would have to stop, and it's only 2 points, but they have to be on the circle. So that would be line segment AG, or you can go in the opposite order, GA. The radius, we have two different options here. We could say A to C, from here to the center, or we could say from C to B, from here to here. Also, let me just point out from A to G, that one right there. The next one, the center, that's just a single point. That's center at point C. I'll be more specific. The diameter has to go through the whole circle and the center, so that's going to be this whole line right here, which we're going to say is line segment AB. It's not a line, doesn't have the arrows. And then the last one, the secant, is the line that goes through. Notice we're still using A and G. This is the one that goes through the circle at 2 points. But the difference is we have to put the arrows because it's going on forever and ever. Next part, circles in the same plane. So sometimes we have multiple circles, and we're going to be comparing circles a lot in this unit. They can intersect at 2 points if you have two circles. 1, 2. This probably looks pretty similar because you've seen this as like a Venn diagram. The next one is where they intersect at 1 point. Circles can actually be tangent to each other. It's hard to draw this, but imagine that those circles are only touching once. And then we can also have circles that don't intersect, but there's two different ways for this. So they could just be not touching at all, side by side, or we can have a circle within a circle. Okay, this is called concentric circles. Concentric circles have the same center. That's what concentric means. All right, on to the last part. We can also have circles and tangent lines that intersect at multiple circles. So this first example, we call this an internal tangent because it's a common tangent. It touches one point on both circles, but it's in between the two circles. As you can kind of see, it goes inside of their space here. Whereas this one is external because it's on the outer section of both circles. So it's not going in between the circles. Then we can look at these diagrams. How many common tangents does each pair of circles have? So right now we don't see any lines. We're going to draw in the lines. What you have to think about is imagine that if you were to put a line on top of these circles, how many times could it touch? So we could have one that's an internal tangent here, touches there and there. We could have one going diagonally in the same idea, where it's another internal, here and here. And then we could also have external tangents, here, here, and one on the bottom. It's hard to draw these. So we could have 4 common tangents. The next one, we could have one on the top, could have one on the bottom. Now imagining that these two are tangent, the circles are tangent to each other, you could actually have one going through the middle and then go through that point where the circles are tangent to each other right there. So there's 3 in this one. And then the last one, now we couldn't do one here because this wouldn't make it tangent. So this time we can only have the 2 external tangent lines. Okay. And that one would just have 2. So that is it. Go ahead and try the homework.